Okay, we're doing Inclines 2. Here we have an interesting situation where the cart is not rolling down the ramp because the ramp itself is accelerating to the right. If you accelerate this ramp fast enough to the right, it has to be accelerating, not just moving fast. Then that is going to help support the cart because it's going to increase the size of the normal force enough that the vertical component of the normal force balances the weight, and so all the acceleration is horizontal. So if we look at the maybe tail-to-tip addition for the two problems, for the previous problem, if I add these two vectors together by moving the mg up, what I would get is an F net down the ramp. Here, the n is bigger, so that when I add the mg to it, I get an F net to the right. So that's what's happening here. So again, I'm drawing both diagrams. And if I break the normal up into components, and cosine theta here and sine theta here, the acceleration is flat to the right, so when I write my F nets, it's easy because I know that the y dimension has no acceleration. And in the x component, the x dimension, there's just the one force, which equals mass times the total acceleration. If I break them up this way, well, then I'm breaking up mg, which is, in principle, it's fine. But here's the problem. My acceleration has two components. It has one down the ramp and one towards the top of the ramp there. Make sure it's a right triangle. So when I do this, I'm going to have an MA parallel and MA perpendicular. I don't like breaking that up into pieces, so I know that's not going to be profitable. So I should tilt my axes when the acceleration is tilted. That's why it was helpful for us last time, and not helpful for us now because the acceleration was tilted. Now it's not. You always want the acceleration along one of your axes, so you have a 0 for one of your F nets and an equals MA for the other, instead of an equals MAX, MAY, or MA parallel, MA perpendicular. So in this setup, I'm going to solve for the acceleration. I can do that from here, but I don't know n, so I'm going to find n first from this equation. Solving for n and then substituting into the other. Okay, cancel my m's, and I can combine sine theta over cosine theta. So that's a nice compact little result. So tangent of 20 degrees times g is 3.64 meters per second squared.